Hi friends, MoNaCo here. Congratulations, you made it to the last lecture in this unit. Video 9, Acids and Bases. Reactivity of metals and acid. So at the first unit, first day of the unit, you wrote down in Bellworks that metals reacted with acids. So we're talking about table J today and how to predict if a metal is going to react with an acid. One practice pack page on this material. So we know they react with metals, but can we predict which ones will react more or less? And the answer is, of course, yes. We have a reactivity series table called Table J that ranks the metals according to their reactivity with acids and other things in general. It has everything to do with their ionization energies off the periodic table, but we've decided to chart this in a different location as well. Reactions of metals with acids. According to Table J in your reference tables, any metal located above H2 will react with an acid to produce H2 gas and a salt. So metals react with acids to make hydrogen gas and a salt. Which metal, Mg or Cu, will react with HCl? So you got to just see which one's above the H2, and that's the answer to your question. Let's look and see, Mg or Cu. So we find here, there's H2. And Cu's below it. Here, there's Cu, and Mg is above it. And this is ranked in order of increasing activity at the top. Most reactive at the top, least reactive at the bottom. So since copper is below H2, it means that it will not react with acids. So Mg is our answer for this particular lead-in problem. Mg will react, copper will not. Generally, the reaction is as follows. Metal plus acid makes H2 and salt. Example, zinc plus 2 moles of hydrochloric acid will make H2 and ZnCl2. How did I get Cl2? Well, zinc is a positive 2 oxidation state when it's in a compound, and Cl has a negative 1. So when I cross those down, the crossing down technique, the charge cancellation technique is really what it is, you get 2 chlorine ions for every 1 zinc ion in order to have a neutral compound. So of the 4 types of reactions that we have learned, this is a single replacement reaction, and H2 gas is produced. So this is not really a double replacement like an acid-base neutralization. This is a single replacement that's occurring. Now, there are 3 metals on our chart, table J, that do not react with acids because they are located below H2. 3 are copper, silver, and gold. These 3 metals are classically considered to be relatively inert. They do not like to react things because they're located below hydrogen. Those 3 metals don't like to react with nobody. Hydrogen and acids are no exception. Everything else will react by increasing order towards the top. So the most reactive metal with an acid will be lithium, followed by rubidium, potassium, cesium, barium, strontium, calcium, sodium, magnesium, aluminum, titanium, etc., 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 etc. So if you're trying to make something out of metal that's acid resistant, you probably want to use one of these 3: silver, gold, or copper. Expensive. Reactions of metals with water. Group 1 metals, all group 1 metals react vigorously with cold water. Group 2 metals, beryllium has no reaction with cold water or steam, even at red hot. So some of these metals do and don't react with water. This is a kind of like a side note to the main point here. They make things like hydroxide or magnesium oxides. These reactions with water is not always so clear. Magnesium is a slight reaction with cold water, and magnesium burns in steam to produce white magnesium oxide and hydrogen gas. So I guess what we're trying to show is metals react with water, which I guess can technically be considered an acid sometimes because of the Bronsted-Lowry classification. Calcium, strontium, and barium will all react with cold water with increasing vigor to produce metal hydroxide and hydrogen gas. So metal hydroxide would be formula of XOH, and hydrogen gas would be the situation. I realize I put these in the wrong spots. You should always have the MgO as a solid and the H2 as a gas. My fault. Let's see here. So summary of the trend for group 2 metals down the group. Group 2 metals become more reactive with water as you go down the group. Again, I want you to take away this table J material, reactivity with acids. And we have a whole practice page on that in our packet. So use table J to predict if a metal will react with an acid to produce hydrogen gas or not. If a metal will react with water is kind of a side note and is not going to be on this particular unit's assessments. So thanks for watching. You made it.